chemistry review topic 15% error. Let's get to it. All right, so the formula for percent error is on the back of your reference table in table T, and we're going to go through 3 examples, and hopefully that helps. All right, so here's our reference table, table T on the back. Here is our formula for percent error. Okay, so let me just grab a blank sheet of paper. All right, so I'm going to write the formula percent error, and I'm going to shorthand it. Measured value minus accepted value divided by accepted value times 100. Okay, so let me move this over so I can see the problem. There we go. All right, so while inspecting some of your lab results, you discovered that instead of a final average of 4.55, so the accepted value was 4.55 grams. You obtain a result, so that's the measured value, 4.70 grams. What is your percent error? So let's plug them in. Our measured value, 4.70 minus 4.55 divided by 4.55 times 100. All right, so let's pull up the calculator and let's do that. So the way I would do this is parentheses 4.70 minus 4.55 and parentheses divided by 4.55 times 100 equals. Now, how many significant figures do I need? Well, all these numbers have 3, so I need 3. So my percent error is going to be 3.30%. That's my unit. I have to have a unit. All right, let's shrink the calculator. If your job requires you to always measure, all right, so let's just rewrite this. Percent error equals measured value minus accepted value divided by accepted value times 100. Requires you to always measure out 5.6 liters. So that is the accepted value, 5.6 liters. And you mistakenly fill one with only 5.4 liters. So I have 5.4 minus 5.6 divided by 5.6 times 100. All right, let's do that math with the calculator. So let's clear this out. Parentheses 5.4 minus 5.6 and parentheses divided by 5.6 times 100 equals. Now again, this time I only need 2 significant figures, so negative 3.6%. Now, most of the time it's standard practice to take the absolute value, so it is not wrong to write it as 3.6%. So this is right. This would also be right. Okay, both would be correct answers in that case. All right, let's look at the last problem. Again, I'm going to write percent error equals measured value minus accepted value over accepted value times 100. And we're going to get from our problem measured value and accepted value. So a student in lab measures, so I know that's 4.6 grams. He should have measured 4.7. So measured 4.6 minus 4.7 divided by 4.7 times 100. All right, let's do that on the calculator. So 4.6 minus 4.7 divided by 4.7 equal times, oh, wait, hold on. I did something wrong here. Parentheses, 4.6 minus 4.7 divided by 4.7 times 100. I don't know what I did there, but there we go. So negative, now what do I need? 2 significant figures. Negative 2.1%, or I could write it as 2.1% and take the absolute value. So both would be correct. So there you have it, how to calculate percent error.